Alright, welcome back to Meteorology 101. We are going to continue our study series on atmospheric physics. We're now on part 4, and we're going to cover heat transfer. So this is going to be a really short video. We're going to cover the 4 types of heat transfer, and radiation being one of the biggest. We're actually going to do a video on that separately. So this one is not going to last very long. Let's get started on this. So heat transfer, there are 4 primary mechanisms that transfer heat in the atmosphere: radiation, conduction, convection, and advection. So radiation is a transfer of energy by electromagnetic waves and have electrical and magnetic properties. So we'll cover that, like I said, in another video. We'll cover the aspects of radiation: emission, absorption, reflection, scattering, attenuation, and the radiation budget. So once we get into that, that's a pretty long discussion on albedos, different earth surface types, dirt, grass, stuff like that, that changes the absorption and emission of radiation into the atmosphere. So the angle of incidence is incoming solar radiation from the sun hits the earth, usually hits the earth directly at the equator. It's hotter at the equator, and then as it spreads out in an angle over the earth, since the earth is a sphere, then there's less incoming solar radiation toward the poles. So that's why it's colder at the poles. So the earth emits radiation in all directions at all times, day and night. So the earth is a sphere, so it is always emitting and absorbing radiation in different parts of the earth all the time. All right, conduction is basically, if you think about just the touch, the transfer of energy by molecular motion. The transfer of heat is always from hot to cold. So a perfect example is turning your stove on, putting a pan on that stove. The heat transfers from the hot burner to the pan, so it's from hot to cold, and it's by touch, by the physical molecular touch of the molecules between the stove and the pan that heat up and create that heat transfer. Heat conductivity is the ability of a substance to conduct heat. So if you have a hot metal or just a metal pan you stick on the stove, heating that up versus putting a board on the stove, you have a different heat conductivity of that substance to conduct heat. Is related to molecular structure, the heat capacity, and the density of the substance. So like a metal pan or wood being more dense, the faster the molecules are going to bounce off each other, they're closer together. So as you heat the molecules right at the base of that pan, they're going to move faster through the pan because the molecules are closer together, it's more dense. On a piece of wood, it's less dense, so you heat up the molecules, the molecules right at that surface, you're going to have to heat those up a lot more to get those to interact with the molecules on a less dense product, and then it would definitely take longer to heat that up. Okay, so convection is the vertical transport of atmospheric properties, so heat and moisture. So as you got incoming solar radiation, you get a heats up the surface of the earth, that heat rises, and then you got convection, and you're pulling the moisture up with that convection. So just a heat low, or just an area of low pressure based on the heat incoming solar radiation. That's how you get those air mass thunderstorms. So stable atmosphere, if you're in a stable atmosphere, that suppresses the convection, so that will keep the thunderstorms from happening. And an unstable atmosphere enhances convection. So if you're unstable, as you push a air parcel up, it will continue to go up because it's an unstable environment. If it was a stable environment, when you push an air parcel up, it will continuously want to go back to its original position. So that will suppress that convection. Advection is the horizontal transport of atmospheric properties, heat, temperature, and moisture. So temperature advection deals with the horizontal transport of heat. So we talked about this on our video with the thickness chart. If you pull that one up, then you follow the sea level pressure on the surface chart look at the pressure gradient, and then parallel with those isobars, you push colder air into hotter air, you have cold air advection. If you push warmer air into colder air, then you have warm air advection. So that's the horizontal transport of heat in the atmosphere. So I think that's the 4 we just covered. That ends the show there. So like I said, the next video we will get into the radiation and aspects of radiation, and we will cover the emission, absorption, reflection, scattering, attenuation, and radiation budget. So stay tuned for that video. Right now I want to say thanks for watching, and until next time, get your head in the clouds.